What exactly is the environment? Environment is everything around us, from our homes to our streets, neighborhoods, cities, and countries. It's beaches and forests, deserts and oceans. It's the containers in the continents we live on. It's our planet Earth. When we talk about the environment, we're usually talking about how healthy or unhealthy our planet is. Our environment includes the five essential elements: water, air, soil, energy, and climate. Number one, let's find out more about water. All living things are made mostly of water. Humans are about 60% water. Plants are 80 to 85% water. And the Earth's surface is 70% water. That's why the Earth is called the blue planet. So where is the Earth's water? About 97% of the Earth's water is salt water, which is found mainly in seas and oceans. It's too salty to drink or use to irrigate crops. Only 3% of the water on Earth is fresh water, so it is a rare and precious thing. We use fresh water to irrigate our farmland and gardens, and we also treat it to make it safe to drink or potable. Oceans. The oceans keep the planet's climate in balance. They absorb and store the sun's heat, and that heated water sets ocean currents in motion. The current moves the heat around the planet like a giant conveyor belt. Warm water from the tropics is transported to the poles on the surface of the ocean. At the same time, cold currents flow in deep water. The ocean is home to tiny algae called phytoplankton that are invisible to the naked eye. These microscopic algae are carried down the surface waters by the current, and they play an essential role. Like green plants, they act as small chemical factories. Through photosynthesis, they absorb much of the carbon dioxide from the atmosphere and release more than half of the oxygen we breathe. Threats to the ocean. Building along coastal oceans contributes to the destruction of shorelines that protect against storms, such as sand dunes, cliffs, and mangrove swamps. The flora and fauna that live by the sea are also affected by these destructions. Modern fishing techniques allow us to catch more fish than we can eat. Gigantic nets scrap the ocean floor, collecting not just food, fish, but also species like dolphins and sea turtles. At the same time, the nets destroy coral reefs and underwater habitats. Climate change means more work for the oceans. Oceans have always absorbed carbon dioxide from the atmosphere and stored it in the cold ocean depths. But now there is so much carbon dioxide that the chemistry of the water is changing, making the oceans more acidic over time. An acidic ocean weakens the skeletons of corals and the shells of crustaceans, and it shortens the lifespans of other marine species. Invasive species of fish or algae can be transported from one ocean to another by ships, radically altering the ecosystem they invade. Pollution from the land is contaminating the oceans. Fertilizers and other substances run into the water, and plastic garbage and oil spills kill marine life. Freshwater: 70% of the Earth's freshwater is frozen year-round in glacier ice in Antarctica, the Arctic, and various mountain ranges. The other 30% amounts to only 0.5% of all the water on Earth. It is found mainly in groundwater, in lakes and rivers, and in the atmosphere as water vapor, rain, snow, and clouds. Hydro- Hydrologic cycle: the Earth's water is constantly being recycled in a continuous process known as the hydrologic cycle. Surface water evaporates when it's heated by the sun, whether from a puddle, the ocean, or plants and trees, and rises into the atmosphere as an invisible vapor. This water vapor turns into clouds. The clouds release water in the form of rain or snow, which can be soaked by up by soil and plants or become runoff on the surface. From there, the water flows into rivers, lakes, and spaces underground, and the cycle starts all over again. Fresh water in our daily lives. Everyone uses fresh water. Every family, business, and city or town that provides public services such as schools, hospitals, arenas, or parks will use water to irrigate our crops and feed our livestock. Agricultural irrigation accounts for 70% of the world's water consumption. And we use water in industry to produce goods, to cool machinery, and to transport finished products. At home, most of our water comes out of the tap. We use it to keep ourselves clean, to wash our clothes, to prepare and cook food, and of course, to drink. And we want it to be out of the best possible quality. Depending on where you live, the water in your home may come from a well, spring, lake, river, or stream. This water can be contaminated because of human activity. Groundwater is particularly sensitive to products used in farming, such as pesticides, fertilizers, and manure. Factories also discharge pollutants into rivers, lakes, and groundwater. Water in our bodies. A camel can swallow the equivalent of a bathtub full of water and not need to drink again for a week. But it's different for people. We can go without food for a few weeks, but most humans will survive for only 3 to 4 days without water. The human body is like a sponge. It must have water to work well. All the cells that made up the body need water, and less of it. Our bodies are about 60% water, but our blood and our most important organs contain even more than that. How much water is in our organs? Brain needs 73%, heart needs 73%, lungs need even more, 83%, kidneys need 79%, and blood need 83%. From birth until death, the average person will drink the equivalent of almost half an Olympic-sized swimming pool, and about 80% of the water you drink is absorbed and used by your body. The remaining 20% is excess and is released via your kidneys and bladder. Number 2. The two elements that made up our world is the air. Like water, air is I'm sorry, read again. Number 2. Air. Like water, air is essential for living things, from humans to plants, fish, and insects. Air is a colorless and odorless mist of invisible gases. So what is air? 78% is nitrogen, 21% is oxygen, and 1% is other gases, such as including water vapor, argon, and carbon dioxide, plus fine particles such as dust, pollen, and ash. Holding your breath. We need the oxygen in air to live. We can survive for 4 to 6 minutes without breathing, but after 3 minutes, our brain cells begin to stop functioning. The brain consumes more oxygen than any other organ. Some divers can hold their breath for several minutes underwater, but the bodies have adapted to allow them to do this without harm. They have more red blood cells and bigger lungs, and they take in extra oxygen before diving. The current world record for holding one's breath underwater is 24 minutes. The atmosphere. The atmosphere is a layer of gases that surrounds the Earth. Beyond the atmosphere is the vacuum of space. Layers of the atmosphere. Troposphere, 5 to 9 miles or 8 to 14 kilometers above Earth. This layer, which starts at the ground, is where clouds and weather develop. It's very thin, equivalent to the peel on an apple. Stratosphere, 31 miles or 50 kilometers. This is the location of the ozone layer, which protects us from the sun's ultraviolet light. Mesosphere, 53 miles or 85 kilometers, the transition zone between the Earth and space. This is where meteorites burn up. Thermosphere, 372 miles or 600 kilometers. This is where the International Space Station orbits. Why do we need the atmosphere? First, it protects Earth from meteorites and the sun's ultraviolet rays. Second, it provides the oxygen that all living being things need. And moreover, it provides plants with the carbon dioxide they need to grow. Fourth, it keeps the Earth's surface warm. Last but not least, it reduces the temperature differences between night and day. The auroras, northern and southern lights, are formed in the atmosphere when charged particles from the sun hit the Earth's magnetic field, releasing energy that appears as bursts of light. Wind. What is wind? When the sun heats up a mass of air, the air becomes lighter and rises. That creates an area of low pressure beneath it. Cool air, such as the air at high altitudes, is heavier and it sinks. It exerts more downward pressure, creating an area of high pressure. A difference in atmospheric pressure between two areas causes wind, as air always moves from the high into the low pressure area to balance out the pressure. We feel the moving air as wind. The greater the difference in temperature between the air areas, the stronger the winds. Wind is also affected by the rotation of the planet, and landforms such as mountains and valleys can influence airflow and causes regional winds.